Hey everyone. Hello. Hey everyone. This is Shiv. First, big round of applause to Subham. He is like working with Temporal, and we use Temporal internally for one of our product features. So that's very good product actually. Okay. Coming back to Nudgebee. Nudgebee is a AI SRE assistant and all, right? What I'm today talking about, like he covered a lot of part, like what exactly is agent, how you make agent work, etc. I'm going to talk about when you are trying to use an agent, what kind of problems you are going to face, and how potentially you can fix those problems, right? So you may have heard a lot about what is basically prompt engineering. There's a context, right? How to make all of them work and so on, right? So first question: how many of you have used LLMs in troubleshooting your production environment, or as a SRE where you collect the log, analyze through LLMs, and then basically identify the root cause of the problem? How many of you have used here? Ah, very good, very good. So, any specific challenges which you may have faced? Maybe LLM not solving problem, it doesn't work the way you want it to work, right? Or today I was talking to someone in the morning, right, where he said it's easier for me to write a two-line of code than explaining an LLM, and where it is a kind of messing up with my complete setup and increases my work by 8 hours or 4 hours, right? So they were like facing a challenge which is called a context engineering, right? Where you are trying to feed in too much information to system or not giving it any information and then expecting it to basically work, right? Now, for example, this is where the alerts look like, right? You are trying to debug a particular problem in the night where alert came in, and then you are expecting LLM to basically work, right? For example, there is a issue which is in my payment system, right? You get an alert that, okay, my payment system is not working, right? Now you are struggling with LLM, why it is not working, right? You are trying to feed in some log, then LLM give you a summary that, okay, this is what it means. Then you are going to your Kubernetes cluster, collecting your object definitions, you are going to your matrices, collecting your matrices, feeding in, but it is somehow not working, right? It is just giving you that, okay, crash loop can happen because of these 10 reasons, and you are sitting and trying out, figuring out like why those 10 reasons can happen, right? Instead of how it should have happened, you giving a data, the LLMs or the agent automatically trying out the root cause, giving you a root cause that, okay, this is where the issue has happened. Now, there are like multiple issues or reasons why this potential problem happens, right? First one is general structural issue, right? For example, your infrastructure is very complex, right? What LLM knows is like how different things work with each other, right? It knows your coding, it knows your like what exactly Kubernetes is, what exactly AWS is, what kind of commands you can execute, right? But your infrastructure is very different, right? Maybe you have an application which is talking to 10 different applications. LLMs don't really know about it, right? Your application is basically named internally as a services server. But when your alert is getting triggered, you are saying payment service is failing, right? How LLM is going to correlate these two information, right? That is what all comes under the context engineering, right? Similarly, let's say you're asking LLM to go and collect the log based on a certain information. In your logs, you are saying that, let's say if you are using Loki, right? You are saying that my labels are basically KHS underscore pod. LLM is trying with get me the log of this particular pod where it is using label as a pod. Then again there is a mismatch, right? So all of this information comes when there is a mismatch between what LLMs understand, how much information they know about your infrastructure, and how they can basically generate a query, execute it, and collect the information, right? Another issue which I have observed, a lot of people don't use, let's say, connectors, which is can be MCPs or any kind of CLI command, right? They ask LLM to generate a command, they execute that command, collect the information, then again pass it to LLM. And by doing this, you are kind of spending next 3-4 hours just to collect the command and executing, right? Rather than providing an MCP or giving LLMs access to basically your infrastructure so that they can collect the information and start giving you root cause analysis and more detailed analysis rather than you getting involved into each and every step, right? For example, some of these informations are structural information, right? Which is service map, dependencies, traffic flow. Let's say you have a service A, which is connected with service B, service C. For example, let's say within Nudgebee, right, there is a service called LLM service. That LLM service depends upon authentication service, it depends upon our internal data sources and so on, right? Now, your LLM doesn't really have any of that understanding, right? What it knows that this is what one single service is. If there is an error, it doesn't know if there are like 10 other services dependent on it as a upstream, downstream, right? That is the information which you normally manually provide, right? Okay, this is the error. Okay, I got it. Now go and look into this service. This is what you basically do a prompting to it, right? And it basically collects more information and then get back to you, right? Second is historical context, right? Lot of people or organizations have lot of historical context in terms of their Jira tickets, in terms of their conference and all, right? Now let's say if you are not connecting your LLMs with these system, right? All of that is basically in your mind, right? You are telling and guiding system, go ahead, look into this conference, or go ahead, copy paste data from conference and to LLM chat that, okay, this is what your new context looks like, right? Third one is more like operational, right? There's a easy fix, more like go and restart a pod, right? Versus there is a much better fix, which is go raise a pull request for this particular service so that I can merge it, it follows my CI/CD and then gets deployed, right? And even better fix is the issue is not with this service, issue is with different service. So you don't have to basically increase memory here, go and fix that particular service and then raise a pull request and merge it, right? So those are the information which you normally have as a part of your runbook, right? Which you pass on from one engineer to another engineer, right? Let's say everything is in your head, you leave the organization, right? Now who is going to manage that particular infrastructure, right? They have to learn from zero, right? So that is where a lot of big organizations focus on like build a runbook, build a documentation, etc., right? That is mostly to focus in terms of like, so that if you are leaving, who else is going to manage it, right? Now think about LLMs having access to your documentation, right? Now they know how your system looks like, right? What if there is a problem, how they are going to fix that problem by looking into that runbook, executing those specific commands, and then solving your problem. Third part is basically real-time data, right? Lot of time what I have seen is people thinking in terms of like ingesting all their logs into RAG, right? Your RAG can't sustain that much of log, right? Or basically pushing all the matrices to your RAG system and so on, right? The better way to handle a real-time data is you basically generate a dynamic queries to the system, right? For example, let's say you are using Datadog, or maybe you are using Loki, or whatever it is, right? If there is an issue, you ask system to generate a query, use MCP, execute that query, get the response, and start processing it, right? Rather than you manually collecting the data and passing it to LLM, or basically pushing it into some kind of RAG and then expecting a correct data, right? Because your data will get stale in some time because there's a like live stream of processing or data which is currently happening, right? Similarly, additional information which your infrastructure contains is what is the change which has happened. 90% of the times when there is an issue happens, that happens because there was a recent deployment which has occurred which is breaking something else, right? So for example, if I have to investigate something, the first thing I normally do is like what is basically recently deployed, right? Was this issue happening before that or is it a new issue, right? That narrows down like what exactly you are looking or where you are looking, right? Now, can you provide that context information to your LLM? That when it is doing an investigation, can you tell it that, okay, first go look into was this service recently deployed? What was the recent code changes which have happened, which may cause this particular problem, right? So these are the 5 core information, right? When you are trying to debug a particular information or particular issue within your production, these are the things which you normally track, right? You track what was the recent deployment changes which have happened. Do I need to collect the log, matrices, traces? What and how the dependencies or impacts are, where the historical or structural information I have so that I can go to my runbook, execute those specific command and get done with it, right? Now, Another issue which we have observed when people use LLMs while doing troubleshooting is providing a correct kind of alert information, right? So for example, what I've observed when there is an alert generated by the machines, right? For example, alert getting generated from your Grafana query, right? Or alert getting generated by your Prometheus, right? They normally contain a lot of context information, right? For example, will know there is a alert label associated with it. You can look up what kind of label values you have. And if you pass it to any LLM, right, they can infer that, okay, when this alert happens, these are the services which got impacted. This is the matrix which is getting impacted, right? Versus think someone like we creating an alert, right? Where we just write a one-liner saying that, okay, my UI is down, right? Now, how would you expect an LLM to basically understand this particular one line? What exactly is UI? Is it a deployment within your backend named frontend, or the deployment name itself is the UI? Is UI is a part of 5 different applications, or is it a single application, right? So that is the critical part where the alert information itself is missing, right? And you need a lot of additional context or information to make sure LLM understand what exactly even down means. Is it like giving a 500 error? Are you not able to access the application? Is it giving 503 error? Is it like SSL error? What exactly it means, right? So a lot of time when I have seen people create those incidents, right, they don't provide sufficient information where automated systems can basically pick up, correlate, give an answer, and so on, right? So all of those challenges are primarily the context information, right? Where you are not passing correct information to LLM, right? Versus you saying that, okay, I have a UI, my UI application is down, it is giving me a 503 error at this particular time, and it is associated with this particular deployment. Now LLMs have full picture in terms of like what exactly is UI, what deployment it is associated, what kind of error it is giving, right? It can go ahead, create a query to basically give me 500 error-related logs, right? Or it will look into your matrices to get me all the HTTP errors which have happened recently with the 500 error, right? Or look into your traces to get me all the traces where the error is happening and the status code is 500, right? So now it can basically correlate all of this data, collect to them through MCP, give you a more reasoning around it, right? It can go ahead and look into your GitHub to see like what exactly was the last deployment which has happened, right? So you need to have a proper context in terms of what you are saying. That language needs to be understandable to LLM, right? Now you can explain those languages in terms of either providing it a documentation, your internal lingo to LLM, that okay, when I say UI, this is what exactly it means. When I say service, this is what exactly it means, right? So that becomes your internal language, which now LLMs understand as a part of context, right? Second part, which is more around like when there is an issue happens, right? As an end user, because you have all of that in your head, right? You know like this application talks to this, this talks to this. This is how it is connected, and you know like what exactly is blast radius, right? When as a LLM I'm looking into, right, I only see your application, right? There is no one who is telling me that, okay, this application is correlated with that, right? Now, if I try to infer that, right, I will find something in the log that, okay, there is a connectivity issue. If I connectivity issue, I will tell you that, can you get me access to this particular application? Because that is where I find the issue is happening, right? So you start looking into those from a connectivity or blast radius impact perspective, right? Another part which I think which solves a lot of problem is, one is a RAG kind of system. You don't use RAG to basically push your real-time data, right? That never solves anything, right? What you use RAG to basically store a lot of your context information, right? For example, you can basically pull data from your Confluence, you can pull data from your ServiceNow, push it into RAG, right? Now LLMs can hit the RAG with the particular keyword, they will get all the reference document, and they can start utilizing as a part of next, like how I can solve this, right? Second, you can basically have a investigation memory, right? For example, every time you are using LLM, you are trying to solve something, ask it to remember it for the next session, right? So that when next time you are talking to it, it will reference your previous data and then start solving that, right? Now you can store that as a part of memory in somewhere in the RAG. Or if you are using local session, then you store it into like memory.md or something, right? Where you can ask it, go ahead, remember this for next session. And next time when you are going to solve it, system already knows like what exactly it has done previously and start following it rather than you having to explain it again, right? Then global context, that every time you are trying to solve anything extra, tell it that, okay, this is my architecture, these are the service names, this is how it is, and then system will start following, right? Now, let's say how that basically solves the problem, right? Previously, we were saying that, okay, the application is basically failing because of this. Now, system looks into all the context which you have provided. It will look into your conference data. It will look into your deployment history. It will look into your recent log, memory trace, and it starts solving your problem rather than you providing it like one by one step guide on how to basically look into that, right? Now, okay, so a lot of that basically theory. Now you're thinking, okay, how all of this gets combined into a single place, how you basically exactly solve this particular problem, right? So I have couple of examples in terms of which telling like how exactly all of this looks like in practice, right? So for example, this is, let's say, one application error, right, which happens within our own infrastructure, that, okay, our RAG server was having some kind of issue, right? What system did it? It looks into our GitHub. It basically identified, okay, what were the PRs which have impacted that particular file, right? Now, even before doing that, it basically collected the log. It basically identified, okay, there were like failures from the error. It identified this was the particular line where the issue was. Then it looked into GitHub, identified the pull request and so on, right? It also looked into the CPUs, memories, etc. None of them were relevant, so it just skipped them, right? Now, once it has all the data, it started generating an investigation, generated a log analysis, giving a summary that, okay, you have this issue because of these potential PRs, and this is where the, because system can connect to your GitHub, it went into GitHub, proposed the code fix that, okay, this is where the issue looks like, right? Now you can start a conversation with that, like, okay, you have identified it, can you go ahead and do more about it, right? So you can basically ask it, can you confirm if the particular fix is going to work, right? Then system is going to your Postgres, verifying it and telling you that, okay, that the fix will going to work, right? And then finally, you can go ahead and raise a pull request or save it, right? Similarly, let's say you have an issue in your AWS infrastructure, right, where a particular load balancer started failing, right? System collected a lot of information in terms of like, okay, first, like how the service map or how that particular application is connected, what were the matrices around it and so on. Then it started doing its investigation, and when you go to investigation, it generated a lot of AWS command based on the information now it has available, right? It started looking into your load balancer because it can connect to it. It will start looking into your security group and so on, right? Once that is available, system basically gave a root cause analysis that, okay, your load balancer was failing because it has this issue with the security group. And then security group, you can basically go ahead, identify and so on, right? And then you can ask system to basically go ahead, can you go ahead and fix my security group itself, right? It will go generate a task and then go ahead and fix your security group itself, right? While doing this process, it also creates its own memory that, okay, there was a security group issue with this when I have identified, this is how my applications are connected with each other, right? So now it has basically all of that information. Similarly, you can configure, let's say, your knowledge bases that, okay, this is where the confluence lies. Now system can go ahead, look into your confluence for any kind of future issues, right? Any kind of memory which it is collecting, you can basically find all of those memory which is available or system has learned by looking into different investigation or by talking to you, where you can say that, okay, can you go ahead and remember it for the next time onwards, right? So, and you don't necessarily have to use something like Nudgebee for you, right? These are like general concept when you are doing a troubleshooting in your production environment, or building a AI agentic layer which can do a automated troubleshooting for your production system, right? You need to take care of like what kind of information you are passing. You need to take care of, it can connect with your documentation system to understand more about you. You need to take care of like it can do a live query to your log, matrices, traces, and so on, right? So yeah, that's it from my end.